Let's take up more reactions of alcohols and phenols. First is acetylation. This is very important reaction. Salicylic acid. What is salicylic acid? 2-hydroxybenzoic acid is reacting with acetic anhydride in the presence of H ion and result in the formation of 2-acetoxybenzoic acid. Common name is acetyl salicylic acid. It's commonly used analgesics, antibiotics, and for heart patients to dissolve blood clots or act as blood thinner. So aspirin is formed from salicylic acid. Side product is acetic acid. Next, we are taking reactions involving cleavage of carbon-oxygen bonds in alcohols. These reactions involving cleavage of carbon-oxygen bond take place only in alcohols. Phenols show this type of reaction only with zinc. Reaction with hydrogen halides, reaction with phosphorus trihalides and pentahalides, and dehydration of alcohols. So first we are taking dehydration of alcohols. If we have alcohol and we heat with H positive ion, alkene will be formed plus water will be formed. Let's take up specific example of ethyl alcohol in the presence of H ion, that is concentrated sulfuric acid. We heat OH from here and H from here is removed and double bond is formed between these two carbon. We get ethene plus water. Ethyl alcohol reacts with concentrated sulfuric acid at 443 Kelvin gives you ethene plus water. Remember, temperature 443 Kelvin is very important. If temperature is 413 Kelvin, we will get ether. So only at 443 Kelvin we get ethene. 2-propanol when reacts with 85% phosphoric acid, which also acts as dehydrating agent, at 440 Kelvin gives you propene plus water. OH from here and H from here is removed and double bond is formed. Tertiary butyl alcohol when reacts with 20% phosphoric acid at a lower temperature 358 Kelvin, OH from here and H from here is removed and we get isobutylene or 2-methylpropene is formed. Now the ease of dehydration of alcohol, tertiary alcohols are most easily dehydrated, then secondary, then primary. Reason is that tertiary alcohol form tertiary carbocation which is more stable than secondary carbocation. Secondary carbocation is more stable than primary carbocation. Therefore, this is the order of dehydration of alcohols. Let's take up mechanism of the reaction. First step is formation of protonated alcohol. Ethanol or ethyl alcohol reacts with H positive ion. H positive ion will form a bond with lone pair of electron. Utilizing lone pair of electron, a bond will be formed and positive charge will come on oxygen. This is called protonated alcohol. It can also be called as ethyl oxonium ion because oxygen has positively charged. Now from protonated alcohol, we are leading to the formation of carbocation. It is slowest step, that's why it is rate determining step. So slowest step is always rate determining step. Protonated alcohol slowly leaves water molecule by giving this pair of electron to this pair of electron to oxygen. So water is removed and here we get ethyl carbocation plus water is formed. Third step is formation of ethene by elimination of proton. Ethyl carbocation, this H positive ion will go away and pair of electron it will give for double bond formation. We get ethene plus H positive ion is removed. Acid used in step 1 is released in step 3. So to drive the equilibrium towards right, ethene is removed as soon as it is formed because otherwise it may get protonated and form alcohol back. Next we are taking oxidation. Alcohols on partial oxidation give aldehyde and complete oxidation they give carboxylic acid. So ethyl alcohol when treated with CrO3 we get acetaldehyde first and finally it may change to carboxylic acid. Secondary alcohol when treated with CrO3 we get ketones. But2-ene 1-ol has got double bond and alcoholic group. We want to oxidize only alcoholic group, primary alcoholic group to aldehyde and don't want to touch double bond. We use PCC, pyridine chlorochromate. PCC is mild oxidizing agent which can convert alcohol to aldehyde but will not affect the double bond. So but2-ene 1-ol can be changed to but2-ene 1-ol. The common name of this compound is crotonyl alcohol and it is changing to crotonaldehyde. Dehydrogenation, that is removal of hydrogen. or mild oxidation. Ethyl alcohol, when treated with copper and 573 Kelvin, we get acetaldehyde plus hydrogen. Removal of hydrogen is oxidation. 2-propanol, when treated with copper at 573 Kelvin, hydrogen is removed, acetone is formed. Tertiary butyl alcohol, when treated with copper 573 Kelvin, we don't get aldehydes and ketones, we get alkenes. Isobutylene is formed plus water is formed. Why? Because tertiary alcohols are most easily dehydrated and least easily oxidized. Dehydrogenation of primary alcohols take place very easily. Secondary alcohol less easily. Tertiary alcohol is most difficult to oxidize. And with copper 573 Kelvin, they don't get oxidized, rather they get dehydrated.